Hello. I would like to share with you a short video that should help you with your class assignment, homework assignment on mixture compositions. Some of you may be surprised by the question and might get stuck for until the last minute. And I wanted you to start early during the spring break, so you can have a positive experience solving these types of problems moving forward. So let's see. Let me share the screen as to what we are talking about. This is the homework you got, right? Use the following formulae to answer problems 1 and 2. This is the set of formulae that I shared with you about concentration, mass fraction, mass percent, mole percent. If you remember, if you don't, go back to the video. And these are the composite equations that came from that. The first box tells you the different forms you can use to calculate mass flow rate of species A. And the bigger box is the series of mathematical transformations that you can use to calculate mole fraction. Molar flow rate of species A. Correct? I think we went over this, and then we even did a problem or two. Here is a problem you've been given, and okay, problem number 1. An aqueous solution of phosphoric acid is flowing into a tank at this yada yada rate, density that. Calculate the value of the items requested below, and make sure you show the full calculations. Okay, just don't write the answer. All right, here we go. Molecular weight of phosphoric acid, molar flow rate of phosphoric acid in the tank, mass flow rate, phosphoric, and the total mass flow rate in the tank, right? Four questions. All it's saying is an aqueous solution of something is flowing into a tank at this rate. It has a density of that, and that's all you got, right? So you have to answer these 4 questions. So how would you even tackle something like this? Let me go back to the screen that I'm share a different screen with you. So let's see if we can tackle this from there, right? So let's forget about phosphoric acid. Let's call it, say, some tank, right? Some tank into which something is flowing, correct? And let's call this sulfuric acid. Sulfuric acid is H2SO4, right? So what's given in this? It's given that it's 6 molar, right? Given. I'm just reading the question, okay? What's given? 6 molar, right? Okay. And then flowing at a rate of 200 liters a minute. So that is what? 200 liters per minute is what? So it's volumetric flow rate, correct? So what is 6 molar? It's concentration, right? Concentration C. Density is also given, right? Density is 1.34 grams per cubic centimeter. That is density rho, correct? These are the 3 things given. So what's being asked? Let's say the molecular weight. First is A is the molecular weight, right? I mean, that's easy. Molecular weight. So what is molecular weight for sulfuric acid? I'm using sulfuric acid as an example, right? So just 2 hydrogen plus 1 sulfur plus 4 oxygen, right? Add all the atomic weights, you'll get the molecular weight. So that's easy. So what's B? Molar flow rate. Right? What is the molar flow rate? So what's the symbol? N, right? It's asking of sulfuric acid, right? Of sulfuric acid. So it's H2SO4, right? So what equation can you use to calculate the molar flow rate of sulfuric acid if you're given the volumetric flow rate, concentration, and density, right? So what would you have to do? If you're given all that, right, what would you have to do? So all you have to do is look at the equations, right? You're asked molar flow rate, correct? So obviously, The molar flow rate is this, one of these equations, correct? This is the molar flow rate. So either this or this or this or this is can use. You obviously know the concentration is given, the volumetric flow rate is given, right? So all you have to do is molar flow rate is concentrations times volumetric flow rate. And going back to the question, is concentration times volumetric flow, but both given. That's the hint, right? What is C? What is the mass flow rate, right? Mass flow rate of, say, sulfuric acid, right? Is equal to what? So obviously you have to go back to the equations, and the mass flow rate equation is here, correct? Mass flow rate equations is the smaller box, and it's either this or this or this or this, right? Since you already calculated molecular weight, it's got to be one of these equations that asks for molecular weight. Like voila, there's molecular weight, concentration, and volumetric flow rate, right? So in A, you have already calculated molecular weight. Concentration and volumetric flow rate are given already. So all you have to do is plug in the equations, correct? Now, you see what I'm saying? I'm just giving you hints. I don't want to do it for you. So mass flow rate is what? Molecular weight times concentration times volumetric flow rate, right? Yada, 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 right? So what is D? The total mass flow rate of the system, right? What is D, right? So you got that, molecular weight, molar flow rate, mass flow rate, the total mass flow rate. So what equation is this? So it's not MH2SO4, right? That's the mass flow rate of H2SO4. The total thing is just that, right? The total mass. Remember, this is where students get confused. Total mass, not just sulfuric acid. So when you have stuck like this, what is the total? How do you calculate total mass? Remember, mass of something is what? Remember that one? Density is equal to what? Mass over volume, right? So this is total, right? Total. So obviously mass is density times volume. Mass flow rate is density times volumetric flow rate, okay? So plug in the density is given, right? Right, density is given over here. That's how you do it, okay? Good luck. I'm going to stop this video. That way it doesn't get too long.